Hey y'all, welcome back to the lab. In this video, we're going to be talking about how to animate a sine wave with p5.js. So I built a sketch that animates a sine wave in p5.js, and here we're going to talk through how it's built. So I have a video of it here, but I've also got the sketch available on Open Processing, which is a cool little platform that lets you run like p5 sketches and host them for free and share them and look at other people's and see the code and stuff. So it's a great little way to create sketches and share it out. And so here's kind of what it looks like. We can see that, it's really just a sine wave and that it's like kind of moving from right to left, right? If we track this curve, it's slowly moving to the left here. And that's basically it. Now for how it's built, the way p5.js works, if you don't know, is it basically has a draw function, and every frame it's going to try and loop through the entire draw function and render it to the screen. And so, it tries to do that as fast as it can. And that's how we're getting this idea of movement, is because we've changed data between frame to frame, and that's what it's ending up rendering to the screen. So basically what we're doing is on each render frame, we're creating a shape to represent the line and render it. You could also just draw it directly onto the screen if you wanted, but we're just using a shape here. Then for each x-coordinate, so going across from left to right, we're going to calculate the y-coordinate by finding the distance from the center percentage, because, in the center we want it max height, but on the sides we actually want it variable height. Then we're going to scale that value from 10% to about 200%. It was 10 to 100%, but I wanted this to be higher, so I made it up to 200% of the amplitude variable, and then placing it by multiplying against the current sine wave value. And that's how we get, it looks like a sine wave, but clearly, the size of these things are different depending on where we are in the sketch. Finally, we increment the phase so that the next render shows the sine wave moved a small amount. And that's how we're getting this like animation look, is because we're slowly changing the phase so that on each render it looks like it's moved a little bit, because we've recalculated where the quote-unquote position of the sine wave is. Now for variables here, I have phase, which is basically the current position of the sine wave, frequency, which is how frequently we see those curves, and then amplitude is how high the curves are. And of course I've got a little bit of extra logic here, so it's not just pure amplitude, but I'm also editing the amplitude based on the position in the sketch of its x-coordinate. So the full source code here, it's not really the full source code, it's really just like the JavaScript code, but this is enough for you to run it yourself in like Open Processing or something. Obviously, if you wanted to like host this yourself, you need some like HTML and stuff, but this gets the point across. So it's all like located here, but we can also look in the editor on Open Processing to show you that this is actually how it works. Sorry, people who like dark mode, I don't think there's a dark mode version of this. Actually, there might be. Oh, nice, dark mode. Okay, cool. And so here, in all my little sketches, I like to put the variables at the top. This is a great way to make the sketches just easier to change, and to also see like what things are supposed to be changed and what things are kind of like static and part of the sketch. We're creating the canvas here with just width and height, which I set up here. Then we draw the background color, and then we basically set up the stroke of the foreground color, weight of 2, and make sure that it's not a fill, because we are creating a shape, and so if we don't tell it no fill, it might try to fill in some random way, which isn't going to look like a sine wave. Then we're beginning our shape here. We're iterating over all of those x values, basically from left to right. We're calculating the distance from center, and this is basically a percentage, like what's the percentage we are from center. Calculating our variable amplitude, so this is 0.1 is the smallest will be of the amplitude, and the largest originally was 100%, because it'd be 0.9 times this. But it's actually closer to about 180, 190%, because I'm multiplying this twice just so that we get more variation in the height. And then we actually calculate the y value, where we get the sine of the frequency, times x wherever we are, plus the phase. So that's how we're actually moving the sine position. We multiply that by the variable amplitude so that the y value actually gets that curve that we want. And then we position it at height over 2, which is basically the middle of the sketch. So that's located in the middle. And then finally we create a vertex there, which adds it to this shape, so that when we actually go to draw it, all those shapes are connected, or all those vertexes are connected in the shape. And then finally, here is where we're incrementing the phase, so that the next time we go into this draw function, the whole sine wave will be moved a little bit, and that's how we get this animating look. Next. Now I haven't played around with creative coding in a while, but I've recently gotten back into it. I'm particularly interested in how the new era of vibe coding, especially with these AIs, can lower the barrier to entry to building whatever you can imagine. Previously, it was like if you didn't understand how like the math worked, or maybe you wanted to try something out in like a new technology like phaser, you'd have to like learn all of this background stuff just to get, an image in here. But with the vibe coding and AIs, they're pretty good at doing basic things for you. So if you tell it like, I don't know, create me a sine wave that moves, or load an image of this, or create me an SVG that looks like this and then make it smaller and bigger. It can usually do those things, which takes away a lot of the kind of boilerplate you would have needed to understand beforehand, so you can kind of focus on the bit that actually matters to you. And as an example of this, like this sketch was built 90% by Claude before I came in to adjust the variables, and I wanted it to be higher, so I changed like my variable amplitude functions, I moved some variables out and stuff, but like the boilerplate itself of the idea of like a moving sine wave, it can one-shot that like very easily. So I'm curious to keep exploring that and, see what else we can build here. Now, if you like this post, you might also like scripting generative art in Python with Pill, which also happens to be like my highest performing video ever. You might also be interested in 1 million checkboxes, globally synced data with HTMX. And finally, the nature of code, traditional random walk using Godot 4 and F#, which is an interesting little combination of technologies. So that's it for this video. Thanks for watching, and I'll see you in the next one.